Okay? Is too loud? Too soft? Somebody give me a thumbs up one way or another. Cool. Awesome. Well, I appreciate everybody coming today. I get the honor of being the last presentation before lunch, so thank you for those of you who did show up. My name's Clint Russell. I'm the Cisco Meraki product specialist covering the Meraki product line within Cisco, and I'm here today to talk a little bit about the evolution of video surveillance. For those of you who are on the SAINTCON network today, hopefully the network is working well. That's all our stuff that we help donate for the show, switching, wireless, firewalls. We also have a handful of cameras as well. And today we'll mostly talk about just kind of the evolution of video surveillance, and then talk a little bit about how AI and machine learning is kind of helping modern day professionals from a security perspective. I also do have 3 water bottles up here. These are not here for purpose, but for those of you who ask questions and stuff that's interesting towards the end of the session, those are for you guys. So little incentive for anybody who is here before lunch. Just quick agenda. I'll talk first about kind of the evolution of video surveillance, what's kind of happened over the last kind of 50 years since the market has really matured, and then talk a little bit about kind of the next generation side. I'll do some demoing, and then talk a little bit about how cameras can be used as a sensor of the real world. It's not just about collecting video anymore. It's really about sensing some things that are happening and then being able to respond to that those sort of events. So first off, from an analog perspective, this was kind of where video surveillance got its early start. In 1942, the first analog CCTV camera was released. And kind of started kind of building this world of video surveillance. And the architecture overall, generally you need a single DVR. You pull in data from these various different cameras. The video from the DVR then feeds into a monitoring system. And then if you want any type of kind of remote viewing capabilities, you have to have some sort of router or firewall to basically pull in VPN information to essentially act like you're on network to view the various video feeds. And from a kind of intelligence perspective, which is a lot about what this presentation will be more about, all the intelligence from an analog camera perspective basically lived in the control room, in the security operations center, where people are basically pulling in the video data, viewing it on walls from a monitoring perspective, trying to see what's happening, make sense of events, and leveraging the people there that are literally actually sitting there watching video, raw video, and then if an event actually occurred, then they have to kind of sift back and pull that. And it worked great for a little while, but big problem with analog, obviously the resolution was pretty poor back in those days. You constantly need people to basically be continuously interacting, and there's no concept of artificial intelligence. It's purely just the control room where it all lived. So in the 90s, the first IP camera was released, and this kind of brought about what today the modern video surveillance-based architecture looks like. And essentially what you have is, it's a very similar architecture overall. Instead of the DVR, you just have NVRs now. They're network video recorders. The IP cameras plug into switches, and you generally have an NVR or multiple NVRs per location. But it requires a lot of on-premise hardware, right? If you got hundreds or thousands of locations, you really need an NVR at every single location to aggregate the video data. And then that video data is then sent back to giant storage arrays to store for as long as you need it. And you also have all sorts of kind of software packages, custom software packages. If you want to actually view the video, typically you've got to download plugins and that sort of thing, unless you're on the network. And maybe the last thing here I think is really interesting, especially at this conference. The NVR is the #1 network vulnerability today. They generally get installed and never patched. I had a customer the other day who was talking about how they had a NVR that was running Windows 98 still. Mind-blowing to me. So just overall, pretty interesting sort of thing. And generally, like, it's just a lot of hardware, a lot of custom software makes it really difficult to view. So with modern CCTV systems, this is a screenshot of Milestone, who many of you guys probably may be familiar with. There's lots of things that you can do. They do a really good job of kind of allocating where cameras are on the map. They provide multi-stream views. There's a lot of pretty easy ways to kind of communicate and interact with the system. But at the end of the day, if you want to do any type of intelligence on the video, you really have to stand up a server array in a data center to actually analyze the video after it's pumped back into something, and then basically run software, custom software on that server array to actually analyze the video in general. And that could be used for all sorts of different things. It could be, people detection, object detection, facial recognition, those types of things. You can do all those today, but it all requires this kind of on-premise data center today. And this architecture has really been unchanged largely since the late 90s when the IP camera was first invented. And if you think about this, like, what's happened since the IP camera was released in the late 90s? Well, in my mind, a lot, and specifically a lot related to both mobile computing as well as cloud computing, right? So, in the late 90s, Google was founded. In October 1999, we had the first GPU released to the market. In the early 2000s, Android was released, YouTube was founded. We had AWS come out, the first kind of cloud services company. Azure was released. And then kind of in the mid to late 2000s, we started seeing like a lot of processing power start to hit mobile markets, right? So the first iPhone was released in 2007 with a whopping 128 megs of RAM and a 412 megahertz processor. But in 2014, in basically less than 10 years, right, we went from 128 megs of RAM to up to 8 gigs of RAM and an octa-core processor inside of a cell phone, right, which is pretty outstanding. And what's interesting is that while all these kind of advancements have happened with both mobile and cloud computing, a lot of this hasn't kind of hit the CCTV market yet. So the idea is, what if we could use the advances in mobile and cloud computing and apply those types of lessons to the CCTV and video surveillance world? From that perspective, you get an entirely different architecture. It'd be a lot different than this kind of data center world that we live in today. So I work for Meraki, and we're not the only ones looking at this problem in this way, but there is something to be said about this architecture. And essentially what happens is, rather than pumping all the video back to a storage array, we completely eliminate the NVR and DVR entirely. We store everything on disk directly on the cameras. And our cameras also have the ability to kind of be viewed remotely from the cloud from any type of device. We use standard web-based video. There's no plugins to install, no custom software packages, nothing like that. And then beyond that, because the cameras themselves have this octa-core processor similar to what's built into the iPhone X or the Samsung Galaxy S10, they can use that octa-core processor to not only view the video, but actually do AI and machine learning at the edge. And in addition, once they actually process or identify something that's occurring on a scene, they can also integrate with third-party applications to do further image processing, things like Amazon Recognition, Google Vision, and some of those other engines that have really powerful AI image processing engines without having to pump it back to a data center and write your own kind of use cases. So that's where things are kind of going. That's the architecture here. I'm going to do a quick demo just to show you what this looks like. And then I'm going to talk a little bit about how the cameras can be used as a sensor with some of those third-party integrations as well. So just a second here. All right, let's see. I think I need to pull this in. There we go. All right, sorry, I should be mirroring my displays because it'll be a lot easier for me than trying to do it backwards. Hold on just a sec. All right, there we go, much better. Trying to do it reverse is pretty difficult. Okay, so for those who don't know, as I mentioned, Meraki is powering all of SAINTCON from a networking and also camera perspective. And Tristan and the folks here were kind enough to give me just read-only access to the cameras as a part of my speech today. So hopefully the Wi-Fi is working well for you guys. Hopefully it's pretty fast. We got Wi-Fi 6 APs powering this thing. But Meraki in general, we make routers, switches, access points, and cameras. For those who haven't seen this is the Meraki dashboard. I only have read-only access to the cameras. So there's a total of 10 cameras that are powering SAINTCON right now. kind of monitoring the various spectrum here. I'm going to go directly into the video wall. And by the way, I'm over Wi-Fi right now, so if there's a little bit of jitter here or latency, don't fret it too much. This is probably a 30 meg plus stream that's going directly to my laptop at the moment. This is a live view into the various cameras. From here on the video walls, we can click on one of these cameras. And let's say we had an event that happened. Maybe somebody lost their laptop and somebody was taken. And we know about the time when it occurred. We don't know exactly when it happened or where it was from. So what we're going to do is just use plain language here and type, say, 3 p.m. yesterday. And by the way, like even with my typos, it should be able to kind of pick up that time. And this directly goes into the camera's view from 3 p.m. yesterday. And we're going to search for some motion that occurred like right here in this little area of the laptop here. So we're going to say, hey, we saw some motion there. Where someone's laptop. Maybe something occurred during that particular time. So I'm going to click on one of these images. And what you're seeing here, there's a ton of, obviously, things going on here. But this is doing something called motion recap. And what motion recap is doing is it's trying to categorize events and show you all of the motion that occurred for a particular event on a single JPEG image, right? So the camera, in this case, it was a 30.1 second event that was detected that had some motion in that area where we were searching. And you're seeing like ghosted images of every single person that was walking during that 30-second image on a single event. The idea for security professionals is, hey, I want to quickly and easily find the event that I care about, because maybe I knew that someone in a green shirt walked by this laptop at a particular time, and the next thing we knew, it was gone, right? So we'll go ahead and play the video here, and this will go ahead and actually do the video clip that we just looked at. Keep in mind, 30-second event. It's recording a little bit of the motion before. You see this individual kind of walk through, and ultimately, someone kind of makes some sort of motion that passes through our area here. So, right, so you go to the clip, you skip some time before and some time after of the area that you're searching for. And by the way, if I want to share this or screenshot this or zoom in, zoom out, full screen, all that is supported as well. And keep in mind, we did this directly from the video wall, so you could even do the motion search at this level as well, which is pretty powerful. Cool. Let's go back to the slides here. So that was just kind of a quick demo of just like showing the ease of the architecture, trying to find the events and stuff. This is something that like today most facilities and security professionals, like trying to find the event that they care about is incredibly difficult. And being able to do that in just a handful of minutes with some plain language, a quick search, and all that is pretty unique to Meraki. But beyond that, what I think is pretty interesting is these cameras also have the ability to be leveraged as a sensor. And so I'm going to demo some of this as well in a second. But one of the examples is our cameras. Again, they have this octa-core processor at the edge. This ability to do object detection. And the first iterations of this include both vehicle and person detection. So you're seeing in this screenshot, we're analyzing images and identifying that there's a vehicle here and also identifying that there's a person over here. And this is fully anonymized and maintains privacy. It doesn't use any PII or anything. It's just our whole built edge AI algorithm running at the edge on the cameras itself. But beyond just the baseline kind of object detection and stuff that's built into the cameras, there's also the ability to actually leverage machine learning to take some of that data and send it into various third-party applications. And there are a few different ways that this can be done. If you want to get a historical aggregate, you can do a query using the MV-Sense API to say how many people were here, for example, at a particular time. Or a current snapshot, how many are here now. Or you can subscribe to a real-time feed to actually have real-time integrations as to when something is detected, either an object or a person or other types of things in the future. I want something to happen, right? So this is all built around what we call the MV-Sense API, and there's a number of other ways this can be done with other manufacturers as well. Just to illustrate this particular example, this is something that's running at Safeway stores today. It's in pilot at a handful of them. And what they do is they have a number of cameras throughout their store, and they built an app for the store managers themselves. And so essentially what's happening is the app is pulling in data from all the various cameras that are deployed in the store and identifying when it's busy and when there's lines, right? So in this case, like you see there's a big queue of people that are kind of waiting to get their groceries checked out. Here on the right in the middle, they basically say, hey, I'm detecting at least 100 people in the store right now. By the way, this is increasing an average of 5% per hour. Maybe this might be per few minutes. I can't remember. And so the store manager with his iPhone actually gets a notification saying, hey, time to add cashiers. There are more than 100 visitors in the store right now. We need to kind of adjust how people are being deployed. So just one example there. Another couple of these things, and again, I'll show a little demo of our motion detection algorithm as well. If somebody is detected or if a vehicle is detected, we have the ability to basically send that image after our edge processing is done to third-party based computer vision services, right? So on the left, this is using Amazon Web Services recognition software, which is really powerful image recognition that basically says, hey, on this image, I've detected a snapshot from the camera. We've on demand said, hey, I want to send the snapshot and then do further image processing on this. And what recognition has done is it says, hey, I've detected glasses with 99.23% confidence. I've got an accessory of 99% confidence. I'm 98.31% sure that there's a person in this image. And by the way, it's a human, and this person is a male somewhere between 35 and 52 with a happy emotional state. Right, so this is something that is the camera detects something, it immediately sends that image back to AWS for sub-second processing, and you can get this image back in real time. Right, so this is how he ultimately saved lives at schools. Right, this can be used for weapon detection today, right now. On the left or on the right over here, this is a different image processing algorithm, OpenALPR, another very cool open source tool for image processing. Our camera has detected a vehicle. It sends the snapshot to do further processing on the open source platform, and it says, hey, I picked up this license plate. Here's the color of the vehicle, the make of the vehicle, the year, and then also it's understanding that we're in a cul-de-sac and in a driveway here, right? So this is really cool. It can be done today, and we're not the only ones doing this either. Last thing I'll show a quick demo of so that you guys can see this as well. Looks like, again, I got kind of, I need to exit out of this, I bet. There we go, cool. That's a good question. It varies greatly based on the kind of algorithm that you use, right? I would say Amazon's recognition is probably the most accurate right now. But in general, the more video and more images you feed it, the more accurate you're going to get, right? So the idea is, like, that's just processing on a single image. If you're continuously sending snapshots every 10 seconds, 30 seconds, a minute, right? It can do further kind of processing and provide better value because it truly does facial recognition as well. So it can differentiate between individuals. What we do at the edge on the camera is relatively rudimentary by comparison, right? Because we're just doing image-based processing to understand what's a vehicle, what's a person, right? And we rely on the third-party engines to do kind of the further image processing there. But you'll see, again, it's still in our infancy, so you'll see it evolve. Good question, by the way. I owe you a bottle. One in the back? Sure. Again, depends greatly on the algorithm that you're using, right? So Google Vision is able to detect guns and knives specifically. AWS recognition has a little bit further things. They even describe things like blunt object, possible weapon, not sure. And the nice thing is you get that confidence level based on the processing for any of the images that are detected, that they can actually kind of, integrate into your algorithm and also provide that value to the rest of your facilities and security personnel. Sure. I'm not sure, to be honest with you. I haven't played much with the third-party stuff on the vehicle side yet. Yep. Yep. So one of the things that I've seen with school districts, a lot of them that have looked at kind of the audio sensors, they already have something in place for that, right? So what they really want to do is say, hey, if my other system that I have that's already doing audio, and it's whether they're using ultrasonic or a number of other types of sensors to detect that. Can I get something from that to also tie into here? And the way that they're doing it, this particular school district in general, is they have basically two different systems, and they're ingesting API data from both. So from our cameras, like they have what they call an anomaly detection. If one camera detects more than 50 people in a particular area at one particular time, they think it's a fight, very likely some sort of thing where they at least need to deploy somebody. So they take that information, they also take those, and they correlate the two together. Yep. We do have baseline audio detection, but nothing for anomalies yet on the audio. Yeah. I apologize. I can't hear you. I'm trying. But again, it's going to depend on what algorithm you're using. These are all very fair questions. I'm not a Google Vision or AWS recognition like expert. It's only stuff that I've played with on myself. But I would say in general, the algorithms are, the AWS recognition has been around for about 3.5 years. It's getting continuously better. You know, in the early days, it did baseline age detection, gender. That's about it. Now you're like far, far, far beyond it with object detection stuff. And ultimately, I think it depends a little bit on how much you're willing to spend with their compute, right? Because ultimately, you know, these are their compute cycles that are doing the image recognition stuff and all that. So fair questions. I don't know the answer. Yeah. Mm-hmm. Absolutely. So zooming in is all still built in. This MV22s like that are all deployed around the conference. These support full varifocal lenses. All the video that we're doing is 1080p. So but you've got 12x varifocal zoom on top of that, based in the dome. So it's pretty high quality video. Yeah. Back. Will higher res camera work better with Google Vision? I would say in general, yes, right? Like the better resolution camera you have, the better image that you're going to send when something is detected to the cloud platform, which is going to in turn result in better, confidence from a object detection perspective there. Absolutely. Right here. Sorry, I'm going to go back and forth to the front and back because we got a lot of people. Yep. The fastest object you can detect. So that depends a little bit on the frame rate of how you select the camera. So our high quality bitrate streams are just 30 frames per second. So we're not going to detect something that's going ultrasonic or subsonic or anything with that. But the baseline image processing that's done at the edge will detect something within every second for sure. So at 30 frames per second, you're going to do pretty good. But we're not going to detect bullets, right? Back. Sure. So this whole SAINTCON network, including the cameras, is all standalone for this particular thing. So Meraki cameras only work with the Meraki dashboard. It's not something that we kind of have a closed loop system in place. Where we typically see a lot of like our customers doing is trying this out at a particular area or in a building, right, first, because they've made a significant investment in one system or another. Yeah, in the yellow, sorry. Just the image, right? So in the MV22 example, it's a varifocal lens. So we are literally zooming here. The cameras themselves, we do not support any pan tilt zoom cameras. We have 360 cameras that support digital PTZs, right? But this is not. I'm not actually moving the lens to focus on this. It's still looking at the full image. I'm simply, as an operator, being able to zoom in, zoom out, etc. Awesome, great questions, guys. I only have 3 water bottles, but those are really good questions. Stop by the Cisco booth afterwards, and I'll see if I can get you some other stuff for those I don't have bottles for. All right, how am I doing on time? Sweet, 5 minutes, beautiful. Okay, so let me go back to the cameras here. And I want to pick on one of these cameras. Let's pick this one in the north. So I talked a little bit about the person detection stuff, and so this is one of the cameras that's mounted here, and we're just analyzing the total number of people that have been detected. And by the way, we'll build these things called motion heat maps to kind of display where we've seen motion. This is just looking at today. Let me go back to yesterday, so we can analyze the foot traffic like over time at the conference. So this particular camera, by the way, this is the type of data that's like accessible via API in real time from the cameras that's being used by Safeway, for example, in their app. But you'll notice, we don't see any motion roughly until roughly 5 or 6 a.m. Between 5 and 6 a.m., we saw 5 people, then 61 at the 6 o'clock hour, the 7 o'clock hour, 589. Then when the conference, of course, the doors opened, we saw a ton. And these numbers aren't the number of people, because keep in mind that these are doing people detection, but it's all totally anonymized. This is the number of entrances and exits that this camera saw, right? So obviously there's not, 30,000 plus people here, but this camera is seeing, 30,000 entrances and exits into its frame of view over the course of this time. And keep in mind, this is one of those cameras that's like viewing like a large portion of the conference here. I can't remember which one this is. This is Cam 3 in the north, so this is in the exhibition hall and stuff. But the cool thing is, like, if you were monitoring an area that doesn't see a lot of motion and you want to like know when stuff is detected or people are detected during those times, obviously you can set that up. You can also set like zones of interest to automatically alert things, and also trigger that API to do further image recognition with something like AWS recognition or Google Vision. So, awesome. And by the way, the cool thing that isn't necessarily by the estimated peak occupancy, we had 44 people that this camera saw at one time, but a total of 406,000 people entrances and exits detected yesterday by this one camera. And this data, of course, is interesting, but as a raw feed. But where you're doing it, the API kind of further recognition on this is cooler. Yeah. So keep in mind, you can do a snapshot of anything at one time, like how many people are here right now. You can do that at any time. It'll do that, and it'll analyze it across all your cameras that you have in that store to do an aggregate count. Yes, absolutely. They certainly could. There are ways that they could kind of take that data and parse that out if they really wanted to. But generally, the trending information is more important than anything else. It depending on how they have the cameras like oriented too, right? Like they could, in theory, just be deployed just at the entrances, for example, and they get a pretty good count of actually what's at the store. Yeah. You can absolutely be double counting. They definitely could be, and certainly we are, right, in this case. But again, this is just raw data. It can be parsed and taken in a lot of ways and accessed via API. All right, well, I appreciate everybody. If anyone has any more further questions, I'll be here all day at the Cisco booth. My name, again, is Clint Russell. For those who are interested in my contact info or want to reach out to me, it's right up there. My slides are posted on the SAINTCON website, and appreciate your time. Lunchtime.